Hi everybody, today we are going to work on graphing what we did yesterday. This should be pretty simple as long as you understood the basic components of graphing a function, which is those input-output tables. So the first step that you need to do is make an input and output table. So I've lined mine up this way, however you can go the horizontal way if you would prefer. So we're going to have the example of my y is going to be 15 times whatever I put in for x. So 15 times 0 is 0. 15 times 1 is 15. 15 times 2 is 30. 15 times 3 is 45. Okay, I have my input-output table. And then you're going to write the input-output table as ordered pairs. So I'm just going to go straight across. The reason I like them vertically when I'm graphing is I can instantly see 0, 0, then it's 1, 15, and then it's going to be 2, 30, and then 3, 45. I put them in parentheses to show these are the various ordered pairs using this input and output table. So now I'm going to switch over to my graph paper and we are going to graph these points. I'll try to keep this so that you can see. And I am going to go like this. And I'm going to go like this. And so I am going to do, let's see. I'm going to do it to a different scale, and since they do go up by 15s, let's see, I am going to do 5, 10, 15, 20, 25, 30, 35, 40, and then 45. And then I am going to do a different scale over here, and so I'm going to do this as 1/2, and this is 1, 2, 3, 4. Just pay attention to what you are doing and where you're putting them. So 0, 0, let me change color here, is going to be right here at the origin. And then 1 over 15 up is going to be right here. 2 over 30 up is going to be right here. And then 3 over 45 up, and I kind of broke the deal. You're going to see my head disappear because I just dropped my ruler. Oh, got it. All right. So the next step after we've graphed the ordered pairs is to draw a line through this function. And what we're doing is I'm going to take a straight edge. I like my straight edge. There we go. And what will happen is this line will continue in either way, in either direction, depending on what ordered pairs we slip in there. So this is my example right here. So a linear function right here is a function whose graph is a straight line. All right, so what we are going to do is we are going to make an X, Y table, and we are going to use these values, and then we are going to graph them. So we know that we're going to put in 1, 2, 3, 4, and 5 and see what it equals. So if this is 3 minus 1, we're going to get 2. 3 minus 2, 1. You see where we're going here, 0, -1, -2. Okay, that'll be our first one. Let's go to number 2, which is, And we're going to use the same values because it told us to up here. So 2 times 1 is 2 plus 1 is 3. 2 times 2 is 4 plus 1 is 5. 2 times 3 is 6 plus 1 is 7. So we're seeing the pattern 3, 5, 7, 9. 2 times 5 is 10 plus 1 is 11. So if we were to graph these functions, so we're going to do this one first. We're just going to make it, each one is 1. So we have 1 over 2 up. Then we have, oops, let me use the other color so it's not confusing. Then we have 2 over 1 up. 2 over 1 up. 3 over 0 up. 4 over -1 up. In this case it's down. 5 over 2 down. And you can see the slope of this goes the other way. You'll notice I did not draw the ordered pairs, but I listed them so they already look like ordered pairs. If they need to do that, or if you're asked to do that on the test, you can simply off to the side do 1, 2, 2, 1, 3, 0. And remember, x is your over, y is your up. 4, -1, and 5, -2. There's your ordered pairs. So finally, I'll try to get this last one. This is example 1. I'll try to do example 2 right here. So I am just going to pretend I've written the ordered pairs, but they're listed kind of like they are. 1 over 3 up, 2 over 5 up, 3 over 7 up, 4 over, and then 9 up, and then 5 over 11 up. And when I draw the line through that baby, you're going to see it goes in a beautiful line right there, and which way it kind of bends and moves. So that's example 2. All right, so I wanted to show you an example in the book that is going to, it could confuse you, but I don't think it's too hard to see. And that is, there are some times when you don't just have a y and x on either side. Sometimes you have an x square or an x cube. And remember, you can have a -2. If y is 4, it could be 2 or -2. So you're going to have points on each side here. And this is not a linear function, meaning there's a curve in it. It's curvy, and that doesn't count as a linear function. This is actually a parabola. If it's upside down, it's a hyperbola. We are dealing with linear, or functions that happen on a straight line. So this is a non-linear function. I wanted to point that out so that you could actually visually see that difference, and know that each time you have an equation, whenever you add some things here like a square number or a square root even, it changes what the graph will look like because you can add those negative and the positive numbers. This is an extension of yesterday's lesson. I don't anticipate huge problems, but just be accurate in your graphing. You will be asked to do that on both the test and the quiz. Have a great lesson.